Hello everyone, myself S.S. Swami, student of Masters in Mechanical Engineering from the University of Wollongong. Today I am going to discuss about the topic production of multi-layer alloy. In this slide, I am going to explain about the introduction, evaluation of the mind map, literature review, research question, followed by the related experiments and design. The entire thesis report mainly deals with specific three research questions that mainly involve the significant sequence of each steps in the entire process of the development of various multi-layer alloy plates. The whole understanding of the specific principle on which the adhesion of the nanomaterial reinforced optimized microstructure multilayer alloy plates on the different variable parts in the field of the machinery is eventually conducted. Thus, the entire analysis will help us to explore the mathematical principle that is eventually applied to the specific model of the Gray-Wolf optimizer algorithm. The usage of the suitable algorithm of the machine learning, such as the multilayer perceptron model, helps us to incorporate the Gray-Wolf optimizer. This entire research work thus helps us to understand the entire process adequately. The principal aim of this entire research work mainly lies to optimize the entire modeling process of the multi-layer perceptions by widely utilizing the Gray-Wolf optimizer. Thus, the entire process of prediction has been eventually done depending on the evaluation of the process of the friction stir. This is mainly based on the aluminum-based process in the field of various significant nanoparticles. In addition to that, this entire research work also helps to pose multiple objectives that involve the framing process of an adequate, optimized multi-layer perceptron model by widely utilizing the specific optimizer. This is the continuation of the introduction section that depends on the analysis of entire process related to the production of multi-layer alloy plates. This also helps us to provide the increased rate of corrosion resistance that also assures various hardening features of the metals as well. Then that the durability has also been enhanced in the overall cases. Effective usage of the carbon mainly lies on increasing the soluble rate in the field of high temperature rather than low temperature process, so that the entire process of transformation has easily been efficient from the previous ones as well. Thus, for that reason, the analysis of all the features of the multilayer alloy plates helps to exhibit high temperature oxidation resistance as compared to the multiple pure metals. These metals are mostly used in the reproduction process of aluminum and chromium. This section mainly elaborates the whole process of evaluation of mind maps. The entire production process has also been made depending on the utilization of the alloy layers as an effective alternative based on the thickness of the parameters. The principal aim of this entire research process also lies in the efficient production of the multi-alloy layer plates as well. One of the most significant reasons behind the process lies in enhancing the strength of the overall metals as compared to the single metal based on reducing the barriers encountered in the overall research context. This section mainly involves the background research on this entire research topic to understand the whole process adequately. Method 1 will use the steps of cold rolling, tension leveling, slitting as well as packaging. Method 2 will include only slitting and packaging. The reinforcement of the nanometal will be done on the alloy production. The nanometal helps to optimize the microstructural attributes of the alloy. This optimization will include a machine learning model used to find the optimum microstructural parameters like Young's modulus, porosity, hardness, elongation, and many more. The machine learning model used here is a Gray-Wolf optimizer that falls under the classification of the multilayer perceptron model. The aim of the research paper lies in optimizing the modeling of the multilayer perceptions using the Gray-Wolf optimizer, so that the prediction has been done based on evaluating the process of the friction stir based on the aluminum-based process of nanoparticles. This research also poses several objectives that include the framing of an optimized multilayer perceptron model using the optimizer to predict the mechanical properties of aluminum alloy and to analyze the microstructural properties of the friction stir process based on the reinforced aluminum process of nanoparticles. This is the continuation of the literature review section that includes the outcome of the definitive methodologies that helps to explore the grain size as well as aspect ratio along with the microrange value of the hardness. A pure aluminum and titanium layer is the most effective for the thickness of the alloy which is developed on this research work. This is generated with the heating and stamping which is created by removing the metal sheet. All the effective paths are created for the multi-layer paths to grow the effective scenario which is built with 5 sample paths. In this case of melting alloys in the air, the slag produced helps in protecting the alloy from the several issues of oxidation. This helps to demonstrate the rate of the process along with some unavoidable issues. The rate of the process allows the controlling of the composition process that minimizes oxidation process. Some of the issues that have been witnessed, especially in the cases of decarburization and the evolved iron during the issues of the steel, so that the removal of the oxygen has been done from the liquid form of liquid in a vacuum degasser. Some of the issues have been witnessed, especially in the process of decarburization of the evolved iron during the issues of the steel, so that the removal of the oxygen has been done from the liquid form of liquid in a vacuum degasser. The research question of this report will begin with the understanding of the necessity of nanometal reinforcement of the multilayer alloy structure. The significance of the analysis of the new composition after reinforcement will be discussed. This study will include the evaluation of the Young's models of the structure priority in order to determine the hardness. The related experiments and design can be clearly seen from the picture. The summary of the entire experiment process is to obtain an alloy with uniform mechanical composition that can be applied as wearable parts to prevent wear and tear in the machinery. This optimization will include a machine learning model used to find the optimum microstructural parameters like Young's modulus, porosity, hardness, elongation, and many more. This slide mainly involves the summarization of the section that helps to understand the mathematical modeling adequately. The summary of the entire equipment process will be to obtain an alloy with uniform mechanical composition that can be applied as wearable parts to prevent wear and tear in the machineries.